All right, today we are going to learn about line notation. Basically, it's a shorthand for describing cells. I wish I could have you drawing the cells. I think it would help you see it better, but I realized early on that that would just be frustrating for both of us, me trying to grade it and you trying to draw it. So I decided we would skip that. And hopefully, with what we are doing, you are seeing basically how these are set up. So an anode is always where you're going to start. So it's always going to be on the left side, left half of the cell notation, the line notation. And then the cathode is on the right. So the first thing you have to realize is, okay, the anode is what's oxidized. So once you identify what's losing electrons, that's what's going to be on the anode. What's gaining electrons, so electrons, if it's losing electrons, electrons are a product. If it's gaining electrons, electrons are a reactant. And so this is going to be the cathode, which is the reduction. I started to write cathode above there. And so that's where those go. We're going to separate them with a single bar and a double bar. The double bar separates the anode from the cathode. We are going to, I don't care if you use a capital I in Arial font or if you use a small L, just trying to get those double lines like that. And then, of course, the single line is when we separate the phases. And the phases are basically the electrode, what's in solution, and the electrode and what's in solution. If there are no solids in something, then we will always resort to a platinum electrode. And our very first one has that. And so here we're showing that this is what got oxidized. Magnesium went from 0 to +2, so it lost electrons. So it's the anode. And you have your magnesium in solution. So we're going to go ahead and use magnesium as an electrode solid. And then we separate with the double bars again to separate the oxidation from the reduction or the anode from the cathode. And so, and this is going to separate what's in the solution and what is the electrode. And so you can have more than one electrode because you can have a solid electrode along with a gaseous part being blown over it. So you can have gases in there too, by the way. And so here we see we actually have two solutions. So both of these were in the reaction. So permanganate went to manganese. And so these are both going to have to be in the solution. And then you're going to have to bring in a platinum electrode because there is no solid here. And so I said that, well, these don't even match these. So I'm not sure what's going on here. And so you run spontaneously in the direction that the standard cell notation is positive. So you reverse the one that gives you the so that you'll get a positive one, and that's what we did in the last assignment. So you should be familiar enough with that. And you should give this basically gives us the direction of electron flow, and so we are assigning an anode and a cathode and give the line notation. So this one does match. You've got your equation matching what we're going to be doing for the cell notation. I'm not sure why the ones on the other side didn't match. They showed two different things, and I apologize for that. Write a balanced equation. So the very first thing we see, if I am going to get a positive one, this is the one I'm going to have to reverse, and I'm not going to get very many voltages out of this, but I'm still going to have to reverse this one. So this is going to be the substance oxidized. So therefore, this was a cathode. This one would be the anode. I said that backwards. Dang gum myself. This is the anode. This is the cathode because it's reduced. So I try to always remember it. I just show you how well my memory is working right now. These are both vowels. And, so that's how I remember oxidized anode, reduced cathode. And so this is what we've got going on here. So what we're going to do is this, since this one's getting reversed, I am going to start with my anode, which is going to be the reverse of this. So this is what's going to be the first one mentioned. So here's the reaction written. So again, this is the anode. This is the cathode. And so when we take a look at this, here's the drawing of it if you were drawing it. Since there is no solid over here on this side, we are going to have platinum as it, but you see that solid silver here, and so you can use a silver electrode for this electron flow. And so you put both solutions, both ions in the solution for the electron transfer to occur. So here's your different states of matter. So here, all of this is your anode. And again, I wish we could take the time to draw these. It would help your understanding of these, but trying to draw them and submit them, I just realized was just going to be a nightmare. So I have Fe plus 2 and Fe plus 3, the ferrous and ferric ion. So I am going to have to put those in solution, which means I'm going to drag in my platinum electrode. So notice the electrode goes first, the aqueous solution goes next. Now we're going to bring in our double bar to say, okay, we're ready to talk about what's happening on the cathode side. We go back up to the reaction. The cathode side has silver and solid silver. So I'm going to put the silver ion in and the solid silver as the electrode. And so we end with the electrode. So we're going electrode to electrode here, basically is the path of flow. All right. So that's how you do a line notation. If you need to get on your cell phone and do a YouTube for a couple more line notations, feel free to do so.